everyone, this is Byte Chunks, and today we're going to go through this problem here. I found this on the web. I was searching for two-pointer algorithm problems, and I found this one, so that's great. This one is really beginner friendly, and I think it's easy to understand. Okay, so I'm gonna leave you with this, so you can actually pause the video and read it through. So I'm just gonna leave you a couple of seconds. So I'm gonna guess that you've already read this since you're here right now. So I'm just going to go through these two examples if something wasn't clear to you, so I can additionally explain it. So this is our number of books, and all of these are actually the times of that it takes to read each book. So for the book on index 0, it takes 3 minutes to read it. Index 1 minute, etc., etc. And this is the time limit that we have. So this number is the time limit that we have. So we have 5 minutes to read some amount of books. So what the rule is, we have to read those number of books, but they have to be, in a row. So for example, if I wanted to read 3 and 1, we will have 1 minute left. But I can't read further, even though we have this one over here. We have to go through 2 first, and that is above our limit. So to solve this case, we would have to take this one as our starting value, then go to 2, and then go to 1 again. So this would be our substring. For this example, we can choose either of these 3 because we can't have more than one, because those 2 would be 4 and those 2 would be 5, and we have originally 3 minutes, right? So what I want to go through first is the naive solution, so what you would probably think of first. Okay, so we have 4 books and we have 5 minutes to read some amount of books. So the naive solution would be to go through each starting element. So we would have this as our starting element at first, and then go through as many books as we can until we reach the limit. So it would be 3 and 1, and we can go further. So what we would do now is we would go from 1, and then we would go to 2, and then we would go to 3, and that would be 3. So our new maximum would be 3, our previous maximum would be 1, so we would just update that. And then we would again go from 2 to 1, that would be 2, we won't update anything because that's less than our maximum. And then we would go through just 1. So, what's wrong with this solution? Well, nothing is inherently wrong with it, except for the fact that it's really slow. So if we take a look at our time limit here, it's 2 seconds. And if we take a look at our value limits, our n can be up to 100,000. And we have to always look at the worst case scenario here. So in the worst case scenario, we would have to go through the entire array from our starting element, which if our n is maximum, so if our n were to be 10 to the 5th, we'd have to go from 10 to the 5th, then 10 to the 5th minus 1, etc., etc. Then we'll go 10 to the 5th minus 2 until we reach 1. And this looks like that one Gauss equation, right? So that would be 10 to the 5th plus 10 to the 5th. No, this would be shit. No. Okay, this would be times. Imagine that this is a multiplication sign. Right, 10 to the 5th plus 1 divided by 2. And this, in programming practice, would just be 10 fuck. In programming practice, this would just be 10 to the 5th times 10 to the 5th, which gives us the O notation of n squared. This is very slow. This would equal 10 to the 10th, which is very well above our limit. So we have to think of another solution because this brute forcing, it just won't work in this example. We can notice one thing now. Say that we were to start from this, and then we would go all the way to here. So we would update our counter to 3, sorry. But then after this, we would have to go from 2 to 1, and then we would have to go from 1 to 1. But what do we know about this? This 2 and 1 is a substring of 1, 2, and 1. So unless the first number is negative, it would always have to be less or equal to this original string. But it can't even be equal to it because if we can see from our limits, our n is always going to be, our a of I will always be 1 or more. So that basically means that this subarray 2 and 1 is always strictly less than our array 1, 2, and 1. So what we're basically doing here is we are doing this repetitive algorithm for no reason because we can't think of anything else. However, there is one thing. A two-pointer algorithm works as a way to, have a left boundary and a right boundary to check, pairs or triplets or whatever numbers, and if they fit the criteria. So what we could do here is have variables of our boundaries. So we'd have L would be our left boundary and it would be equal to 0 at the beginning. And we would have our right boundary R also equal to 0 at the beginning. And this 0 and 0 are actually indexes. So if we could just index all of these numbers, just a second. Right. So we would now go from index 0 to index 0 and see. Okay, so 3 is at our index 0 and it fits the criteria. So we would move our max. Second, our maximum would now update to 1. Because our maximum would actually be right minus left. Second, okay. So now let's update again. Let's say that every time that we have, some substring that fits the criteria, we move the right index, by 1. So what we would have here, so we would, instead of right being 0, right would now be 1. So what that means is that we would have these two numbers. We would have these two numbers now. We would have 3 plus 1, which is 4, and it's also less than 5. So we are now yet again going to move our right index, and now we're going to move it to be 2. So we already have this covered, so we would go through this index as well. So now we come to a problem because this is 6 and our limit is 5. So what we would have to do now is actually move our left index to the right. So we would take this, delete it, and our left index would now be 1. So let's see. We have 1 and 2. And then we will go to 1 again since this is less than 5. And look at it. Now we have 3. Our max would be 3. I forgot to update it earlier to 2. And yeah, that would be our finished task because our algorithm would finish once we get right, the rightmost index to be this, the last index of our numbers. So what we did here is we shortened the algorithm by a lot. And I'm just going to demonstrate how much a lot is. So for one number, let's pick some index. So let's pick this number 2. This number 3, sorry. We would only have to iterate through 3 maximum of 2 times and minimum of 1 time. And that is because the first time we iterate through it is when we add it to our, maximum subarray. And the second time is if we, conditionally have to remove it from the subarray. So that would be 2n. So that would be 2 times 10 to the 5th complexity, which would definitely be within our bounds. And since, in, coding competitive programming, 2n is literally just equal to O of n. So we shortened this algorithm by a lot just by adding these bounds, right? And now the question is, how do we implement this algorithm into our code? And I'm just going to show you what I coded for this problem. So now we're here in Visual Studio, and I've coded this in C++, but you don't have to, necessarily understand all of the syntax if you are programming in another language, because I'm going to be thorough in explaining. So this first bit is just, inputting all of the values. So n is the number of books, and t is our time limit. And then we have a vector of books. You can also use an array here. Oh my god. You can also use an array here. The reason I use the vector is because sometimes when you use an array and you, input, the number of characters in the array to be a variable, it doesn't work sometimes, especially I think in Visual Studio. So that's why I used a vector. But if you're using some other compiler, you can probably use an array, though I wouldn't recommend it. Okay, so we're inputting this, and here we have our bounds. So our left bound is 0, and our right bound is also 0. We have our current time, which I will explain in a minute, and our maximum value, which is 0. So now we have a while loop, and our while loop is basically till the right is equal to n. So this loop will go on until we reach the final element of the array, so our right bound will be the last element, which I explained earlier. Now our current time actually, serves to give us a comparison to the maximum time that we can use and the given time from the task. So each time this loop iterates, our current time will increase by books of the limit right, and we will increase our right bound. So what could happen now is we would have current time plus equal books to the right and right plus plus, but we are not yet checking if this current time is within the bounds of our query. So this is exactly what we're doing here. So while our current time is more than the given time, so if our current time is more than the limit, we are decreasing the current time from the left bound, which is exactly what I explained here on the whiteboard, and we are moving the left bound to the right. So this is basically shrinking our array size to the right. So we are basically kind of moving the array to the right through each iteration where the current time is more than our limit. And the last thing is we are checking if this, so if our current right minus left, so if our current maximum of our current array is actually the maximum. So what we're doing is we are changing the maximum according to the bounds that we have previously set. If you are not accustomed to this syntax, you can also literally, this is the same thing that I did here. So you can use an if statement. You would do if right minus left is more than maximum, set maximum to right minus left. So these two basically the same thing. This one is shorter, that's why I used it. And at the very end, we are just outputting the maximum here. I think that this algorithm is beautiful because it's so easy to implement, and it shortens the code. I mean, it shortens the time that the code is compiling so much. So yeah, this is basically the whole solution to the problem books, and I did it using two pointer technique. Um, yeah, if you want to see more videos like this, I'll be sure to, publish some. This is my first video, so if you liked it, please like it. I guess please subscribe to my channel if you want to continue your coding journey, because this is basically what I'm going to be doing. So yeah, thank you so much for watching, and see you next time.